Uh, Hello, everyone. Thank you very much for inviting me today to talk in women in construction. I'm very happy for this. My name is Alicia Nemad. I am the founder of Architecture Extrapolated, and we have been working for the last 12 years at the intersection between digital design and construction. Not the worst of it. The worst part is that only 5% of on-site construction industry is owned by under 25s. That means that there is no one that will be able to capture all of this high-skill knowledge that has taken like years of evolution and adaptation. And who is going to capture that? Who will be the next master builder or the new digital master builder, as I prefer to call them? Now, on the other end, like 39% of employers rated the skill of the new starters as satisfactory or below expected. So there is really a clear necessity to capture this high skill knowledge and transfer it or attract new talent skills. Today, what I would like to talk with you about is about digital construction and about how we are moving slowly towards a human-machine partnership. Uh, what I want to explain is like to take you a little bit through the journey of architecture extrapolated of RX and to kind of explain how my career has led me to believe that human augmentation through intelligent fabrication can change the design landscape in a significant way, more than any of those two would do alone. And which I feel is the current situation. So, like for me, like the concept of a human and machine integrated collaboration on site in the realm of the digital is what moves construction towards a new strong shift that can take us like into like a more advanced stage of where we are today. So let me just explain a little bit about the current situation and what RX has defined or identified as the main problems that we want to address. So the first thing is the construction industry. We can see that high skill trade, high skill labor is being replaced by very low skill labor. Now, that is a problem because tacit knowledge that is on a high skill trader cannot just be embedded and automated by a simple machine. Like we know that robots and all of these kind of machines are not really smart, to be honest, yet. So knowledge is being lost. The construction industry is battling a skill shortage. But it's even more important in a context, specifically like the one in the UK, is that 25% of the masters with on-site skills are leaving in the next 10 years. That will result in a shortage to the construction industry. But that's not the worst of it. The worst part is that only 5% of on-site construction industry is owned by under 25s. That means that there is no one that will be able to capture all of this high skill knowledge that has taken like years of evolution and adaptation. And who is going to capture that? Who will be the next master builder or the new digital master builder, as I prefer to call them? Now, on the other end, like 39% of employers rated the skill of the new starters as satisfactory or below expected. So there is really a clear necessity to capture this high skill knowledge and transfer it or attract new talent into the construction industry. If they are not enough strategies with current practices, we need to invent new practices that could be attractive to them. And the most important problem for me is that as construction industry gets increasingly digitized, trades are not participating in it anymore. It's becoming only a game of the big players. The second problem that I find is the design. So the built environment needs from customized solutions. And we know that digital language in architecture has moved from one of mass production to one of mass customization. As designers and architectural offices, and we see how we need for more customized solutions, somehow the construction industry has moved towards mass production. And the last problem is like when these two come together, automation and the current solutions to the construction industry and the design industry. So automation in the building industry has limited applications and a limited vocabulary. And we can see that architects, as we are embedded with like new ways of designing, new forms of creating geometries that are more efficient, structurally efficient, that create less pollution and use less resources, the construction industry is not able to fabricate them. It's still fabricating boxes. So how can we understand what is happening? How can we use new technologies like simulation, robotic fabrication, and materials in a smart way that can allow for a future where the construction industry is moving towards mass customization, more efficient use of the resources, less waste, and more importantly, less pollution. And we can see that big companies control 50% of the market, of the construction market, but they are only 1% of the construction industry, of the people. So that means that there is 99% of the construction industry who makes for the other 50%. No one is addressing that. And we are every time increasingly hear more about prefabricated, about these solutions of houses made in factories. And on the other hand, manufacturing homes and companies, how can we train for collaboration requires a very different set of skills and the skills of the on-site master builder. Additionally, we see that transporting these big volumetric houses or volumetric pieces on site requires from like a very different set of skills that is not currently available to on-site construction industry. Off-site construction workers, they don't have people with the knowledge and expertise. They need to recruit people from the manufacturing industry and then train these people into some basic construction ideas, but they are mainly coming from knowing how to work with machines. There's not a middle ground between these two companies, between these two areas. Additionally, SMEs represent 99% of all the construction industry, turnover of more than 63% with a total annual business of 290 billion pounds. And what we see is that they cannot be part of the digital economy because all of these machines are very expensive. They have a very high entry cost, and they need from very specialized facilities, which a normal SME contractor might not be able to provide. So that means that as designers, we move towards digital manufacturing and towards digital industrialization of our sector. These technologies are leaving a big part of the industry behind. Another study that is like dedicated to like see, okay, when we actually transport these big houses and these big volumetric constructions, we have to design for the transportation unit. The design is based on the size of the lorry that we carry them. Additionally, this design has to be able to stand forces of brake, acceleration, and all kinds of design forces that are not normally linked to a building, which is not actually being meant to be moving around on the road. What does this mean? That actually there is redundancy in the construction process. The prefabricated units that we kind of cherish and are so, we are like so much loving every day more, actually create a redundancy of materials and not exactly efficient on the resource utilization. Like, we know that we are kind of thinking that houses are kit of parts, like if they were cars, where we just like prefabricate all of these, assemble them then, and put them together and prepackage them into your house. Now, houses becomes car, city becomes machine. It's a kit of parts that gets constantly repeated as a solution to all the problems. We know that this is not true. We know that houses require from very customized solutions. We also know that there are a lot of stock that needs to be retrofitted, that there is a lot of situations in which we need to address a market that is not just a scarce, that can be built on a perfect factory, that can be built and just come out to the street. We need to address construction sites that might already be working. We need to retrofit. We need to be on places that might have difficult access, that might be remote. The McKinsey Institute recognizes that 87.5% of the construction market cannot be efficiently addressed with modular and grid-based construction. And what are we doing about it? How can we merge the capabilities of the machines that are now off-site with the capabilities of the humans that are on-site? And try to create more expressiveness, efficiency, a more efficient solution, sustainable, and also try to create a built environment that minimizes resource utilization by questioning why do all the volumetric construction are boxes. Is there an inherent problem on the geometry? Can we efficientize that? Or the only problem that we face is how to make better boxes. So that's how we started Architecture Extrapolated started to exist. to look at geometric solutions that could be built on site and cannot have a higher cost than a normal concrete solution. So that's how we started to build this first shell learning from Candela in 2011. Now, why do we look for a shell? Because we know that shells are the perfect mix of a structure and form. The form represents the structure is the form, there's no redundancy. This shell was designed using form finding software, but was built fully on site using traditional skills and traditional workers. We use machines to kind of a router, a simple router that could be available anywhere to like cut the formwork. Like now we know that one of the biggest problems on building shells is that the form has to be built twice in the formwork and in the final product, duplicating the material, giving very large construction times and making them very expensive, not only economically expensive, but also materially very expensive. In this case, we managed to create a waffle solution that was tailored, that was like very smart, and that could describe the full shape on site. This with like less than 20 MDF boards. This shell was built from start to finish in 10 days. Now, by using software technologies that architects are using now for form finding methodologies, we could find a shell that was very efficient in its shape, but we could also customize on the edges to be known that we are not dealing with double curvature, but everything could be only curved on site and could be done using traditional machines. Then we had to describe the shape to the builders. Of course, we had to like maybe let go a little bit of our high technology in this stage because some parts are difficult to translate, but everything could be just put together on site. So the workers became very much part of the process. We were like, what machine do they have? They don't have like a bending machine for tube. Okay, they were going to do it like my feet. They don't have like how to describe the shape on the space. Okay, we're going to give them points so that they describe it based on the height. And so we were working with them and trying to make them also become excited and learn how can they produce these techniques on site without having to report to prefabricate it. So this shell was built by Architectural Extrapolated in 2011 in 10 days with 5 centimeter thickness, which correspond to the H5, which was all bent on site. After we finished this shell, it really kind of shows that the existing local craft combined with digital tools has great potential. What is more, like the workers were very excited. A lot of them would come to me and say, like, we're always just building like regular slabs. This actually was very exciting. We built something that we don't do every other day. We want to learn more about this. They were working overnight. All of it was like paid hours, but they were like really kind of excited, and we could feel how we really became like a team. And it really shows that using digital tools from the beginning of the design process can make building shells or building non-conventional geometries as efficient and as effective as building a regular structure, with the advantage that in this case, form and structure are the same. There is less material used. The whole shell has a very like a small thickness. It's quite is like 5 centimeters, which can be considered very low considering the large span. This has been standing in Mexico City for like now almost like 8 years, for survived for 3 earthquakes, and it hasn't shown any cracks. So we could like really kind of start to be confident that actually there is a lot of potential in merging digital technologies from the very early stages of the construction process and bringing this on site. Based on that, we kind of started to have a lot more confidence and try to like push a bit further. So then we started looking into additional digital technology, digital design technologies. We came to topology optimization. Topology optimization is something that has been used for a few years now, and it's especially attractive to engineers because actually it means that you are reducing concrete usage to up to 60% by removing it from the parts where there is no forces flowing to the structure. So we have the shell, we run a topology optimization algorithm, and we realize that most of the shell is not really working. All of the areas are holes. We can just get rid of that material. We kind of have 60% concrete less. Considering the pollution rate of concrete, this is great. Now, of course, this started to require a lot of adaptations. How will the reinforcement bar will be laid out if there is no like a longer span and a shorter span? So we work very closely with our engineers, which was like Matsumoto Saki. One of our collaborators worked with Matsumoto Saki at the time, was like kind of really much informed of how can we actually describe the rebar. And so in this case, we could produce huge savings on the material and also expressive shape that is kind of very characteristic of current architecture and very much customized for the site. Now, in this case, how can we do the formwork? And the only reason why we need the formwork is because these complex 3D shapes cannot be understood by humans in the same way that they can just mark a rectangle on the floor. So we had to again go to our old friend, the CNC machine, CNC these contours, and be able to just produce the shape on site, describing how the rivers were distributed, and they were able to construct it again in 10 days, again, 2 weeks. And this shell is very different from the first one, because on the first one, the distribution of the rivers was normal, like a rule of thumb, like longer spans with the thicker ones, shorter spans. In this case, there wasn't a shorter span and a longer span. It was all mixed. It was very complex, but the shell still was built in 2013 and it's standing and it's still there. So we kind of realized, and the construction crew was getting every time more excited about working with us. So then we said, okay, maybe we can bring robotic fabrication also on site. Now, robotic fabrication with the idea of being at the intersection between these 3D geometries that exist on the screen on the digital world. A robot can understand the digital world because it's basically plugged into a computer. A robot is basically a computer that can understand the digital world. And the humans, which cannot really work cannot really understand this digitality and this digital space. So based on that, we started to look at different aspects of how can we actually also start to look at new materials. In this case, we're looking can we rethink the brick? Does the brick need to be a rectangle as it was conceived more than 500 years ago? I mean, is this actually something that still makes sense? Or could we have a brick that can allow us to create new geometries and a new vocabulary that is more ad hoc, more according to the new technology that we have? But in this case, we were thinking, okay, how can our clothes, our phones, every other technology that we have has advanced, whereas the way we live and the material that we used to build have remained the same. So we started to look at different constructions, the construction techniques, different materials, I think in the brick, also looking at 3D printing. How can we use 3D printing to embed a lot of this NP in already in the facade, in our facade panels, in the way we work and in the way we build, and kind of rethinking the house and the frame and the spaces, and how can the frame through the new technologies, through the design technologies, can actually start to become part of the inhabitable spaces. Why do we still live on lots, on open plan spaces that were pretty much pioneer in the 1920s? Why can we not start to move to a domestic architecture that reflects actually its production method? And its production method is not the same as it used to be before. It can include robotics, it can include new techniques. So this is a lot of the work that we have been doing, that the Architectural Association, kind of really trying to rethink domestic architecture. What is how can we start to organize, create an AI for a special organization of communities, a team for housing, as we like to call it, where people can have a decision on who they want to live to, what are their preferences, and what spaces of their house they need. We start to question why is it the case where every single house still needs to have the same amenities, like a bathroom, a toilet, a kitchen, a bedroom, a living room. Do we need all of these, or can we just select what do we need? Can we just decide how organization and spaces can change? Why we cannot do that? And this kind of research of thinking, how can we rethink materials and how can we rethink the way we live and the way we build, brought us to this the collaboration that we extrapolated 2 years ago with the Research Group at Shuri and Co. We would like to propose a new technology that could embed a lot of this knowledge and trying to work with them. So they had developed a knitted formwork, which was not really ever used before to all concrete. In this case, it was the shell was going to be described by a cable net embedded into the knit. The knit was going to then stay in place. And the idea was okay, how can we bring this and create a scaffolding that will just hold it? So we kind of brought together again the same crew on this, trying to find new techniques and new ways of building. We brought the same crew. We told them okay, in this case, it's an museum. We cannot have any foundations. Everything has to be self-supported. Everything has to just has to be self-contained. So we kind of started to design everything with the idea that there won't be anything touching the ground. It's all temporary, and the full shape is going to be described on fabric. We don't need to create any of the formula that we had to create before for the topology of the shell. In this case, it will just be brought, expanded, and then you have your shape. So we work very hard in like kind of in the hierarchy of components, like this, on like what needs to be digital, what can be human made, because it's not that everything needs to be digital, everything needs to be robotically fabricated, but there has to be a hierarchy of components where we understand, okay, there is this fantastic skilled workers that are excited because they are starting to interact with digital technologies. What can they bring to the table? What part of what they do, of what is their skill, we can keep and enhance through the digital technologies that we are applying, rather than just bring everything offsite and bring it to them. So then this was the link that was created on the page 2. And this was the scaffolding that we had brought with a lot of, with being very rigorous on the dimension, on the leveling, on every single stage. Then the fabric was brought from Zurich to Mexico City again, and was tensioned on site with through the cable net that was previously inserted on it. Now this gave us the frame to which then like concrete was hand rendered on top of the shell. After the concrete was hand rendered, then we could remove all the scaffolding, everything that was made used to hold it on site, and then we had like a beautiful concrete shell that was never touching the ground and that was never described with any other means than its own fabric, that its own formwork, which then remained on site as part of the expressiveness of the interior face of the shell. Now, in this case, we were also we were using double curvature, so there were like all of these aspects of areas where the concrete might not normally adhere or might not normally go. We had to work with that. We work with like inserting these modeling balloon to create like a cassette kind of structure, as you can see here, and optimize even more the use of the material and reduce basically the concrete weight, reduce the use of concrete to the whole structure. It was all hand rendered by very skilled workers. And what was the main takeaway from this is like kind of thinking, well, how can we start to really mix these two worlds together? So like we have all of these ideas of new materials, of new technologies, of robotics, and we also have these skilled workers and skilled labor. And how can we bring them together to create more efficient, more expressive, and more sustainable construction? And that is where our interest lies. And the other thing is, by bringing all of these new technologies on site, we can also start to attract new talent, because now we have younger people that are getting excited to participate in this economy. And additionally, SMEs can also become participants of this economy because we are bringing technologies on site. We are not recurring to the only big players. And that's our research, that's our work, and that's where we see the future of a sustainable construction industry. Thank you very much.